Experiment to measure the angle of deviation of a prism. Place a prism on a white sheet of paper and trace its boundary ABC. Fix two pins T and S on one side. Place the prism on the boundary ABC. Looking through the other side, fix two more pins Q and R in such a way that all the four pins appear to be in the same line. Remove the pins and mark their positions. Join TS and RQ and extend them to meet the faces of the prism at P and O respectively. Join PO. TP represents the incident ray. PO represents the refracted ray. And OR represents the emergent ray which is bent towards the base. Let PN and ON be the normal at the points P and O respectively. And let I be the angle of incidence and R the angle of refraction. If the incident ray TP is extended forward and the emergent ray RO backwards, they meet at M, forming the angle OML. Measure the angle OML. This angle is called the angle of deviation. Angle of deviation is the angle through which an incident ray deviates. By measuring the angle of deviation for various angles of incidence, we can determine the angle of minimum deviation and refractive index of the prism. The shape of the graph obtained by plotting angle of incidence along x-axis and angle of deviation on the y-axis shows that for a particular angle of incidence, the angle of deviation is least. The corresponding angle of deviation is called the angle of minimum deviation. If A is angle of the prism and D is the angle of minimum deviation, then the refractive index of the prism is given by the relation mu is equal to Sine of a plus d divided by sine of a by 2.